Hello, stream. I just realized I forgot to do something. At the end of all my physics units, my plan was to do the test that is provided, or like do a generated test provided by Revision Dojo on the unit I just did. Specifically for Unit 1 Physics, I'm not going to be doing any of the Galilean quantities because it's something I don't need to know, for at least for me. So I'm gonna mark this for now as not finished, but I'm gonna count the unit as done, because the unit itself, like, we don't need to know that. Question bank specifically here. Let's go through, let's say, 5 questions of each. Kinematics, HL paper 1A. Ooh, actually no, these might take a lot longer. Okay, then I'll do 2 questions of each. I'll bring the music back on, and we'll go from there. No breaks through this, so even though actually I'll take my Pomodoro 5 minute break right now, and then when I get back, it's basically I'm just gonna do these 8 questions, and then I'm done with physics for the day. Because Unit 1 is done. That was my goal for today. I now have Wednesday, Thursday, Friday, and Saturday to finish Unit 2, if I want to stay on pace, to have enough time to start radiation and nuclear energy before the start of the school year. I still have um, like 16 days. I have 2 weeks and 2 days. If I can get this unit finished in 4 days, then I have 12 days to finish 2 more units. Assuming those both take 4 days, we can finish those. And then because I won't be familiar with the radioactivity unit and what is it called? The quantum physics. There, the big buzzword. Because I won't be aware with that, I don't think I'll be able to finish that unit in 4 days. But if we keep consistent physics studying like this, we should be able to. Unfortunately, we will have to cut into some days. Specifically this week, Thursday. I'm warning you now. I won't have power because there's a typhoon going on right now, and our building does power outages when events like this happen. So I'm not going to have power from 10 a.m. to 4 p.m. So I'm probably going to use that time to do my EE or IA writing in a cafe somewhere that does have power. Um, and that means I'll probably have to do double the amount of time tomorrow, or at least like 1.5 amount of time tomorrow, and then do the same thing on Friday to keep myself a bit sane. The plan is after I do these 8 physics questions, after my Pomodoro break, I'm gonna do an hour of a math review sheet that I need to finish, and then I was supposed to do an hour of SAT, but due to the fatigue and also the fact that these questions are gonna take a toll on me, I don't think I'm in the right brain state to do English hard SAT questions tonight. But I will start doing them daily because the SATs a month and a basically less than a month and a week away, and I need to bring my SAT up to at least 1400 because we're at only 1300 right now, and that needs to go up. 1400, 1450, and then I'm fine. I'll leave it there. So yeah. Ooh, this is why I haven't been talking. Also, I don't like hearing my own voice, especially on videos. So I don't like speaking on videos. But um, yeah, I'm gonna take my 5 minute Pomodoro break now, and then I'll do these 8 HL paper 1 questions. So this is like exam level. I probably won't get them right without some help, but that is understandable because now that we've done a unit, we can keep going back to these questions and keep going back to my notes and reviewing for it because I want to get to the stage where I can do these questions consistently. But I'll probably be doing that off stream because I feel like that's easier to do off stream. On stream, I prefer to do the actual studying, which is the part I don't like doing. Is the part I can't focus on. So I'm gonna take a 5 minute break. I'll end my Pomodoro 7 minutes premature. There. Break mode 5 minutes. I guess I'll put this up and I'll turn off my mic. Actually, I'll turn off my mic. I'll turn it back on and give a small thing before I get back. Goodbye. Hello there. Okay. I'm just gonna take a look at some of these questions really quick. Ow. Okay, so multiple choice. Oh, these are okay. These are all multiple choice. These are not multiple choice. Oh yeah, wait. I'm only supposed to do two. I guess I should do one multiple choice, one non-multiple choice, huh? Ow. I should probably do. Oh yeah, what if I do one of these? HL. Hmm. What is this asking? What are the magnitudes of the horizontal components and the vertical components of the acceleration of the projectile P? Okay, that makes sense. That makes sense. Oh, sorry about that. Hmm. I'll put music on. Okay, let's 10x. Okay. So our horizontal component and a vertical component. Well, our vertical horizontal component. Imagine the trajectory of a projectile and the velocity in its trajectory P is located before the projectile reaches the peak altitude, air resistance X of the projectile, acceleration of the projectile at P is A. Actually, no music for this. This is a. Oh yeah, you're right, Hari. I forgot to remove the brake overlay. Yeah, maybe there's a no music thing. Thanks, Hari. Okay. Imagine the trajectory. Blah, 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 blah. Let me think. Ooh, words. Okay. Well, the vertical component is Wait, what? Oh, okay. Never mind. Never mind. So, vertical component is not 9.8. The vertical component would be 9.8 here. No, wait. What am I saying? Isn't it non-zero? Ugh, hold on. Oh. So at peak altitude, that's when our vertical component goes negative. But it approaches. No, it doesn't go negative, right? It's approaching 9.8. Well, no, it's not approaching 9.81. If our vertical component maxes out. Wait, vertical component. Sorry, vertical component acceleration. Sorry, we're doing acceleration. So this is accelerating, accelerating, stops, decelerating, decelerating, decelerating. So this is 0 because it created a perfect parabola. If it was accelerating. No, it would always be a parabola. What am I saying? I think, yeah, no, but the measurement will be different. So I think it is 0. Then, oh, I did not know I could do that. Okay. So here, the acceleration. So we're accelerating, but every, so we're being dragged down by 9.81 every second. So here, we are greater than 9.81, because here, like example, we're still greater than 0. So here is 0. But if these two are like point, yeah. So I think it is A. Shit. Okay. Well, it's C. No, no, it's B. Damn. Okay. So this is a non-zero. Oh, yes. Same logic. Same logic. Because if you throw from here, and you're accelerating, 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 you don't start decelerating, essentially. Or no, you don't start like going back until you also hit the highest point. And you'll still, like, distance-wise, you'll keep going. But acceleration-wise, it should be a non-zero. Actually, if this is what the horizontal component of acceleration looks like, then horizontally it's just continually accelerating. It's just vertically it's not. Which is normal, actually. I don't know why I'm saying it like that. It's normal. Projectile is fired horizontally from the top of a cliff. The projectile hits the ground 4 seconds later. The distance of... What is the height of the cliff? Oh, this is not my notebook. Okay. I'll make a... test questions. This is from paper 1. Okay. Projectile is fired horizontally from the top of a cliff. The projectile hits the ground 4 seconds later. Okay. At a distance of 2 kilometers from the base. Okay. So we have a cliff. We toss. It takes 4 seconds. This is 2 kilometers or 2,000 meters. What is the height of the cliff? Okay. So we can solve this. Oh wait, actually, let me open my where is it? This? No, where's the formula booklet? I know Revision Dojo has one. Hold on. Are you even watching the entire time? That's crazy. Okay, hold on. Open app. Data booklet. Kinematics. Jesus. Okay. Metric unit. Blah. Oh, this is actually like the exact same as our physics text. Wow. Okay. Space-time kinematics. It's obviously not too bad, but shit. Am I dumb? Hold on. Wait, yeah, I am dumb. Hold on. If it takes 4 seconds to drop, then okay, our horizontal component. Oh, I did not mean to do that. 2,000. And our vertical component is our unknown. Takes 4 seconds. Not crazy, right? Then that would be so that would be what? 16. Yeah, no. I feel like I should be able to do this question, and I don't know why I'm not able to right now. Well, it takes 4. Oh, man, this is the one thing. Hold on, I have notes on this. My old physics notes. Oh, I just guess I did not put it in the news section. Hold on. No. I have it somewhere. Hold on. I'm not gonna search this up because I know I have it. Here we go. Nope, not here we go. Wrong one. God damn it. I forgot where it was. Oh wait, actually there might be a formula on it. Maybe I'm just forgetting. I feel like I shouldn't. It should not take this long to answer this question. This is not a difficult question. I'm just being dumb, I guess. What could it be though? Hmm. Yeah, so I'm not wrong here. We're given. Shit. Oops, that is not what I wanted to open. Physics, grade 12, test questions, there. So we're given 4 seconds later, distance of 2 kilometers, which means it was launched at 500 meters per second. Wait, I'm dumb. It was launched at 500 meters per second, and then if we're trying to figure out the height of the cliff, we have the meters per second, and we have the what? Meters per second, distance traveled, time taken. Boom, boom. I forgot the diagram that states like how much gravity starts acting on it. Shoot. Remember, it like changes. Oh, is my stream that behind? My stream is that behind. Jesus. I don't know why I'm stumped here. So it's like we're moving 500 meters down by this much. 500 meters down by double that. Meters down. I have it somewhere. It must be in my exam review then. There's somewhere. Wow. Hold on, I'm not crazy. Oh, I've been using the wrong formula. It's the H formula. I'm so dumb. Hold on. I'm just supposed to use the height equals. God damn it. Height equals 1/2 gravity times squared. That's in. I think that's here somewhere. Or format of such is here. Or no, this was one of the ones you're supposed to remember. Okay, I guess I just forgot it. Yeah, I really need to review the notes. Yeah, so in this case, height equals 1/2. 9.81. That's what I was forgetting, the 1/2. I was forgetting the 1/2. Also, I was forgetting the squared. And we have, what, 4 seconds squared. We don't even need the meters per second. This gives us, what, vertical motion? And then we can calculate. No. This would just give us the height. Where's, oh, my calculator's right here. Bruh. Yeah, I need to review my notes. 4 squared. Yeah, 78.48 or approximately 80. Yeah. The work done by a centripetal force on an object that moves in a circle at constant speed is the work done. Oh. It's moving at constant speed, so I don't think any work is being done, right? Yeah, I think. Yeah, it's 0. Okay. A force acts on a box of mass 10 kilograms. The graph below shows how the acceleration A of the box varies with its displacement D. What is the work done by the force on the box? Force acts on a box of mass 10 kilograms. The graph below shows okay. So here, what we have, jeez, acceleration, displacement. So it's displaced by 2.5 meters, and it caps at 4 meters per second. During its displacement, then it reaccelerates again. So our work done will be this plus this, right? I believe. Force equals mass times acceleration. Actually, so then it's just this. If I'm not crazy. The displacement shouldn't matter. All displacement is telling us is that it's stationary in the middle. I think. Unless I'm crazy. So acceleration of oh, that's why. Okay. Wait. What am I saying for force, bro? For work, I mean. That is not the right formula. I have a formula booklet right here. What am I doing? Work equals force times. I mean, wait, no, I'm solving for the force. What am I saying? What am I saying? I'm solving for the work. What am I saying? Oh, I'm dumb. Supposed to find F and then just. Ugh, Jesus, bro. My brain is fried. Okay. So the force applied is mass by total acceleration. Well, that doesn't work here. Ari, can you help me here? If you're still here. Wait, hold on. Let me reset my thing over here. Okay, he's still here. Alright, in this question, oh, Jesus. In this question, I'm supposed to add, like, here and here, I would have to add the force applied to get total force. Actually, why am I saying this aloud? It makes sense when I say it aloud. So then, for F equals MA here, so F initial, actually, F total equals R M1A1 plus M2A2. So it's mass is obviously the same. And then we get what, 40 plus 60. So you get 100, and then if we plug that into the work equation, work equals force times displacement. 100 plus. Ah, shit. A brain is not braining. Because if we just use F equals ma regularly, we get 10, yeah, we just get 60. And then we get 60 times, it'll be force applied, which is 60, and total displacement of 10. So 600? No. Yeah, that's what I'm thinking. So then 150 plus 150, 300 is not an option, yeah. Bruh. B. To find work done by the force, recall that work is given by. So you solve for F under the area. Oh, I forgot about area underneath the graph. Oh my god. For fuck's sake. Calculate the area underneath the acceleration curve between PMO. PMO. God damn it. It's just Pythagoras theorem, bro. 2.5 squared plus 4 squared equals x squared. Ah, fuck. Okay, well, I guess I might as well do it now. So, for the first one, it's easy. So what it's... yeah. 2.5 squared plus 4.5, not 4.5, 4 squared, that is not the squared symbol, 22.5, and then you do on the other side, we do the triangle first of 2.5 squared plus 2 squared, and then we do the rectangle in the bottom, which is 2.5 times 4. Hari, I don't have any Pomodors left. I'm just doing these questions, and then I have like an hour of math to do, and then I'm going to sleep. Maybe, or I might. I mean, I could call you for a bit. So 42.5 is our total force applied, and then we multiply that. Wait, no, that's still not right. Maybe I just did it wrong again. Hold on. Wait, let's check the answer. I already did this, bro. I have infinite energy, so it'll just show me. To find the work done by the force, recall that work is given by work equals force times change in displacement, where F is the force and change in displacement is the displacement law. Okay. Since the graph shows acceleration versus displacement, use Newton's second law, F equals ma. The area under the A versus D graph gives us ADD, since F equals ma. The work done is W equals mass multiplied by force, acceleration, displacement. From the graph, the area under the curve of a trapezium is 1/2 area 1 plus area 2. Change in displacement, where A1 is 20, A2 is 10. The rectangles. Oh no, the triangle. Oh, like this, and then this. Oh, I did the wrong rectangle. I did the wrong rectangle. Hold on. So this is different. Yeah, this one's different. So it's actually 4 and 5. So it's 20. Bruh. So it's 52.5. Bro. And then 52.5. Yeah, so then that gives us 375. Man, okay, yeah, I need to review my notes. What time is it? Okay, 5 more minutes essentially. Actually, not 5 more. How much? Yeah, 5 more minutes of physics. And then I'll do an hour of math. And then I'll sleep. Although I'll take a break before that. Delivery drone follows a predetermined, route over a city. The drone starts from point O and flies 10 kilometers north to point A. From point A, it changes direction and flies 6 kilometers due west to point B. After reaching point B, the drone flies 8 kilometers south to point C. Finally, the drone. Okay, so it's made a rectangle. Total distance traveled, bruh. Okay, that's just 10 plus 6 plus. Oh, hold on. That's 10 plus 6 plus 8 plus 5. Wow, that is what? 29? 13, 16, yeah, 29. 29 kilometers. Right, it's not displacement. Determine the total distance the drone travels during the entire journey. Great answer. Lovely. Calculate the drone's net displacement, 0. Both in magnitude and in direction. What am I supposed to say for direction? Oh, from point O to point D, sorry. Wait, no, it starts at O, ends at... Wait. Oh! Misread the question completely. Okay. The drone starts from point O, so... Oops, I do not want it to grade everything. Jeez, my bad. O goes 10... I should write this. O, 10 kilometers to A, and then goes 6 kilometers west to B, and then from B 8 kilometers down south, 8 kilometers down south to C, and then we fly 5 kilometers back, so we're not all the way back on the line for O. 5 kilometers, and then that is where our point D is. So we are 3. Oh, no, we have to get the... It's a triangle. What am I saying? We need to get the hypotenuse. So you have 2 kilometers, 1 kilometer. Oh, what? So square root of 5? Yeah, I think so. 1 plus 4 equals x squared. So equals x. Yeah. So square root of 5. I really forgot a lot of physics, huh? Square root of 5. I don't know what direction it was. Oh, like north, northwest. Northwest. Great. Oh, was I supposed to simplify? I guess I was. Show full mark scheme. Nice. Did not provide magnitude as numerical. Okay. Oh, it wanted me to calculate the degrees. Oh yeah, I could have done that. I had. Yeah, okay. That's what it meant. My bad. Okay, well, I don't care about the square root of 5 equals approximately 2.24, because I don't feel like Leeds would care. Oh, I don't feel like my physics teacher would care about that. But then, I mean, no, he probably would, but like, you know, not like this. Whoa. What the hell just happened to my Apple Pencil? Not again, man. What's happening? I don't know what was happening. Um, Okay, I'm just a bit. Yeah. Okay. Yeah. I could get the tangent. I know what I'm supposed to do. I just forgot. What is the what is the displacement from point A to C in terms of both magnitude? Okay, now I know. A to C. Just another Pythagoras. So this is 6 kilometers. That's 8 kilometers. So our displacement is 36 plus 60, so it's 10. 10 meters. Sorry. 10 kilometers, I mean. And then the angle is tangent theta, and then we have opposite over adjacent. From A, I'm assuming it wants us to get it. Wait, let me just make sure they're using here tangent. Oh, they just plugged it in. That's probably better, huh? Wait. Oh, yeah, no, they just... That's dumb. I don't know why you would do that, but... Okay. Arctangent. 84, approximately? So do I just write 84? Math. Symbols. There's no approximate symbol, is there? That's dumb. I'm just gonna write approx 84 degrees. Please tell me that's an option, huh? Come on. Surely that's an option. I would be surprised. What? I'm just gonna write degrees. Surely the AI is advanced enough to read that, huh? Great answer. 10 kilometers, approximately 84 degrees. What? Am I dumb? I am dumb. Oh my god, bro. Slime me out, bro. Slime me out. I'm so dumb. I used the wrong measurements again. I did 6 over 8. Oh my god. Man. Tiny mistakes, bro. Tiny mistakes. If the drone completes the route in 1 hour and 15 minutes, calculate its average speed and average velocity. Okay, so we just use our... Oh, wait, my taskbar is over here now. I don't like that. Okay. Our average speed and average velocity. Ow. So we can use our, what, displacement. We have time. We have displacement. And... Oh, hold on. Oh, wait, I'm over time. I should stop. I need to do math. Okay, hold on. I'll come back to these Revision Dojo questions tomorrow. I have to do math. Hold on. Wait, I'm going to take a 5-minute break, though. Hold on. Ooh. Yes? Okay, sorry. I'm going to take a small 5-minute break, and then I'll come back to do math. Hey, we are back. I am loading up the math slides now, or slideshow, singular. Oh, my cursor is over there. This is the wrong one. Hold on. Here. Oh, did I close it? I must have. Hold on. It's in my Google Drive. I already started on these. These are just basic trigonometric functions. This is like test review for our trig functions test. I'll move these back. And the formula booklet is actually, I can close this. I can access that later. Okay. What question am I on? I am on question number. Nope. Wait. Tutoring. Where did I get to? I don't remember what question I got to. Hold on, let me check. I think I have it saved somewhere. I must have saved it somewhere. Recently accessed. Oh, I have it here. And then we're gonna do a 1 hour session of this, or just until I finish the questions actually. And then I'm gonna go to sleep because it is it's not pretty late, but like I don't want to be working this late. That's not what this was supposed to be. No, not here. Not here. Here. Solution. Here. No, not here. Here. There we go. So my last answer was this one. 7. So I had done this one last, so this is the next one. It's a calculator question as well. Okay, let's do this the right way. Let me open my stream. Okay. Cool. So we have. Wait, let me. Can I slideshow? Oh, I can slideshow format this. Question 7. It's a calc question. I guess I'll write it in my tutoring section as well, just so I can show the tutor. Bro. Let's turn the AC on. Okay, I'm gonna play music. Okay, I'm gonna do a quick answer check. Oh wait, let me open the solutions. This one. Let me bring it over here. Oh wait, I have to turn off this. Then go back here, drag this guy over. Bang. And here, question 8. We have, what did I get? I got B, I got, okay, well, I got 4 cosine squared theta plus 4 cosine theta plus 1 by converting into 2 cosine squared theta minus 1. C, I didn't have question I, like the first one, so I don't know what that one is, but I'm assuming it's just like, I don't know actually. Maybe it's just referring to this. Oh, okay, wait, let's not look at other solutions. And then 2, I got cosine negative 1/2. Oh, that's not good. Oh, it was still connected. Okay, that's not good. Cosine negative 1/2. And then cosine's negative in these 2 quadrants. Oops. Yeah, cosine's negative in these 2 quadrants. So then I just did our 360 degrees and our negative 360 degrees, put our 2 lines, we get 120, 240, negative 120, negative 240, which, did we get? Yes. And then, okay, there was another method where you could just graph it, but I didn't want to do that. And then D, all you have to do is find the y-intercept, which is 9 on the calculator, which I'll show the camera, I guess. Oh, I moved it. Shit. Hold on. Wait. I'll calc for its value again. There. There's our y-intercept. Okay. How many more questions? Fuck. There's 22 questions, and I'm only on question... Final end at 1 a.m. I'll end at 1 a.m. I'm only on question 8. Non-calc. Okay, let's do this. Let's get the music back. Let's do this. Let me turn my mic off. That was a very easy question. Let's check our answers. I got, okay, before I even open the answer key, I got P equals 30 and Q equals 4. P equals 30, because obviously visually amplitude is literally 30. And Q equals 4. Well, you can use this formula. Period equals 2 pi over Q. And then our period here is pi over 2. And then you just do the math thing, and then you get Q over 4. You don't need to do this. I mean, you can do this. You don't need to. You do not need to. Okay. Next question. Question 9. Let's get my mic off and the music on. Hello, I'm back again. This was a decently easy question. Let's check before I do anything. Let me see my answers. I transformed in the first equation by converting our cosine 2x into 1 minus sine x squared, or sine squared x. And that gave me p equals 6, q equals -1, r equals -2. I factorized. Wait, let's check that first. I factorized. Oh, this is the wrong page. Okay, nice. And then let's go back. I factorized it and got 2 sine x plus 1 and 3 sine x minus 2. And okay. And then I got I couldn't identify the solutions, but it just says number of solutions, and it's 4, because the -1/2 will cover this, and then the 2/3 will cover this, which means we should have 4 solutions. I just don't know the angles. And yeah, okay, that's all it was asking for. Because originally I was trying to solve it. That's what most of the time was spent on, was trying to solve it. But you're not able to because of the sine x equals 2/3. You're supposed to list the amount of answers. I mean, you technically are able to. It's just like without a calculator, you can't. You know? Okay. Question 10. Let's get the music on and my mic off. go until 1. But I do have to end prematurely. I will check my answers for this question at least. I finished part A. I got -1 for AI, and I got like 200 for AII. So let's check those answers. Escape. Oops. Ooh. Okay, I got this wrong. Oh, it just okay. No, I understand that. I understand that. Okay, it's like wait, but we weren't given right. We weren't given it. No, I guess it's just assumed. Just multiplying the regular range of 360 by 2 or 4 pi. Okay, that makes sense because it's 1/2, and then you move it. And it's 4 pi. Okay. Today was a productive stream. Today was a productive day in general. Did some good stuff today. Unfortunately, the power outage caused it to be kind of impossible for me to stream in the afternoon. But that will not happen tomorrow, or today now actually. It's already 12:30 a.m. But that will not happen today. I promise I will stream during the afternoon, for real. Especially because the day after, on Thursday, I will not have power during the time I would like to stream, and I will be using that time to work on IAs and E's, so probably no stream on Thursday, and if there is a stream, it'll be late night again. But tomorrow's expect an afternoon one, and it should be an afternoon one. If it's not an afternoon one, then that's my fault. It's been fun. See you guys. My goal for the rest of the week: finish Unit 2 of Physics, review Unit 1 of Physics questions. Because as you could tell from this stream VOD, I'm not good at them still, even after doing the review. Finish this math, but I might do that off stream. I don't know. I'll get back to it tomorrow. And I've got to do some SAT tomorrow, and for the rest of the week. All right. See you guys.